Let's try an example to calculate the probability in rolling a fair dice once. What is the probability A of obtaining a 5 or 6? In this case, the simple event of interest will be 5 and 6, which is equals to 2 number of events. Your space will be equals to 1, 2, 3, 4, 5, and 6, which is equals to 6 numbers of simple events. The probability of A will be equals to the number of events divided by number of space, which is equals to 2 divided by 6. Simplify the fractions, you will get the probability of 1/3. Next, we look into the section B. It is looking for the probability of getting an even number. An even number will be equals to 1, 3, and 5, which is 3 numbers of events, and the space will be equals to 6. The probability will be equals to 3 divided by 6. Simplified, you get half of the chances. Next, we look into another example. 5 coins are tossed simultaneously. The question asks us to find the probability where at least one head turns up, assuming that the coins are fair. You know that tossing a coin will give you either head or tail. A fair coin will give you the chances of half-half. Based on the principles of the probability will be equals to the numbers of events divided by number of space. First, we determine the number of space. This can be determined through the tree diagram here. Assuming the shaded circle represents the head while the blank circle represents the tail. So you are tossing 5 coins simultaneously. That means the tree will have 1, 2, 3, 4, and 5 levels. For the first coin, it will be either head or tail. The number of simple events will be 2. While you're entering the second layer, it will be distinguished based on the head or tail of the first layer. For the first coin, which is head, there are 2 possible outcomes, either head or tail. As for the first coin, which is tail, there is also 2 outcomes, which is the head and tail. Same principles goes to the level 3, 4, and 5. You may expand the tree diagram yourself graphically. The tree diagram here will outline all the possible outcomes of that 5 coins. If all the 5 coins are head, it will be in this line. If all the coins are tail, it will be arranged in this line. Different route will give you different combinations of the possible outcome out of the 5 coins. Now you calculate the numbers of the outcome. You see here is equals to 2. Second layer will be equals to 4. Third layer will be equals to 8. And the fourth, 16. And the fifth, it will be 32. This represents a series of numbers which can be simplified in the mode of 2 power 1, 2, 3, 4, and 5. From the diagram here, you will know that toasting the 5 coins, will give you the sample space of at least 32, which is equals to 2 power of 5. Therefore, the n of the space will be equals to 32. Next, we look into the chances of at least one head turns up. From the tree diagram here, you can come up with 32 roots of the coin under different combinations of head and tail. At least one head turns up means that it can be one head, can be two head, can be three head, can be four head, and can be 5 head. The calculations and estimations become very tedious, so we look into another ways to solve the questions. Knowing that for mutually exclusive event, the summations of all the probability will be equals to 1. With that, we can separate the response into two main groups, which are explicitly exclusive, which is between at least one head and no heads obtained from the 5 coins. There will be only one possible outcome when all the coins are tail. With that, you know that the probability of at least one head plus no head will be equals to 1.0. To determine the probability of at least one head turn up, you may rearrange the equations to become 1 minus the probability of no head. You can quantify the probability of no head, which is equals to 1 simple event divided by total space, which is equals to 32. With that, the probability of at least one head turning up, it will be equals to 1 minus 1 out of 32, and the answer will be equals to 31 out of 32.